Hello, everyone, and thank you for joining us for tonight's vBrownBag. I'm your host, Tom Green, and we're here today to talk about Puppet Bolt. Before we get started, we want to get the conversation flowing. We're live on Wednesday nights at 8:30 p.m. Eastern, but not everyone can join in the conversation live, so we monitor Twitter. At vBrownBag is the primary handle, but there are handles all around the world in different languages, different time zones. We're always available monitoring the hashtag vBrownBag. If you have any questions during the live show, any questions for follow-up later, hit one of our Twitter handles or the hashtag, and we'll be glad to assist you with getting the resources you need. As we said, we've got shows all over the world. The latest and greatest webinar schedules are at vbrownbag.com/brownbags. And the videos post Friday-ish after the webinars on youtube.com/vbrownbag. So with that being said, we're going to hand over the Puppet Bolt discussion to our esteemed guests, Lucy Wyman and Alex Dreyer. Do you guys want to introduce yourselves, and Alex take control of the screen?
Yeah, so welcome everyone. I am Lucy Wyman, and I'm a software engineer on Bolt. And I'll let Alex introduce himself.
I'm Alex Dreyer. I'm the lead engineer on Bolt and the product owner for Bolt. Together, we are about half the Bolt team.
Yeah. So today we are going to be talking to you about Puppet Bolt. It is a remote ad hoc task runner. It is open source. It is on the command line. And how this presentation is going to go is we are going to do kind of a dive into the deep end of Bolt and show you kind of a complex demo that I think exercises the power of Bolt. So show you kind of the end result of what you can do with Bolt. And then we will kind of take a step back and walk through the more introductory Bolt concepts. So kind of explain what we did in its component parts and introduce you to the product. So yeah. I will pass it off to Alex, who's going to run the demo.
Can everyone see my screen?
I can.
Okay, cool. Then everyone.
I am everyone, so.
So I'm going to run a plan, and this plan installs Grafana and InfluxDB, and then sets up Telegraph on some agents to talk back to that. A plan is kind of how you script an orchestration workflow with Bolt. While that's running, I will show what the plan looks like. So this is the plan that's running. The first thing in the plan code here is we give the plan a name and we describe what the parameters are so that when the user runs the plan, they can pass in the parameters. In this case, there's one parameter, which is how many nodes to provision. Unless there's already some nodes provisioned, this is going to call this floaty task. A task is kind of a way to formalize a script and make it easy to share and call from plans. And this task talks to, uses a tool we use internally to get pre-provisioned VMs quickly from vSphere. We're going to pick out one of these hosts to be the dashboard. Then we're going to install the necessary Puppet libraries on all of the hosts and collect facts for them. Facts are things like operating system, how many CPUs that we can use later to determine how to install Grafana. On the dashboard, we're going to include a Puppet class, BrownBag dashboard, that uses a bunch of, available Puppet modules from the Puppet Forge to install Grafana and InfluxDB. I haven't used Grafana for a few years, and Lucy hasn't at all, and we were able to get those modules from Forge and get this working in a few hours. So it's a great way to reuse existing Puppet code. Then we're going to, on all those agents, run the vBrownBag telegraph class, and that's going to install telegraph with some of the standard inputs enabled and configure them all to talk back to the InfluxDB. And finally, a plan, just like a plan has parameters to define its input, it can return an output. So if you want to call a plan from some other automation, there's a clear JSON like object you get. Or if you want to call one plan from another plan, it's easy to get the results of that plan and use them. So over here, we can see in a couple minutes, we got the VMs from Floaty. We installed Puppet and gathered facts for them. We then applied the first catalog on the controller. And finally, we applied the second one on both so that we installed telegraph everywhere. And now, by the time I'm done talking, there should be some information in Grafana. And I couldn't quite copy all that, so I'm just doing it by hand. We set up a password. Hopefully I typed in properly. And here we can see we have some information from those targets. And both of the two things that we set up the telegraph agent on are indeed reporting back to InfluxDB.
Ooh.
Exciting. So that was the demo.
Yeah, so I want to take a second and kind of debrief on that because that was a lot of really cool stuff. Mm-hmm. So you had pre-existing templates in VMware, in vCenter.
Yes.
Is that right?
Yes. So the way Pooler works is we have templates in vCenter, and Pooler keeps a pool of running VMs with each template. So I can just request an already provisioned VM from the pool, and it just hands it off to me. So I say what I want and how many of them I want, and it just gives me the IP or the host names of them.
And then there's using existing Puppet workflow, installed the application and configured it to your standards there?
I use existing Puppet code, but this is a completely different. This is a masterless workflow where I put the agent library on there so that I can actually use the Puppet providers to configure things. But instead of having like a master and running an agent in an ongoing fashion, I compiled the catalogs from Bolt here, and then I sent the catalog over, and the catalog got applied just that once, and the results came back. And so there's like the agent package installed, but there's no agent running, and there's no master running. So it's a bit different than the normal workflow. All the code is on my laptop.
Oh, great. Okay. Thanks for explaining that. I just wanted to make sure, because I was looking away and we had a fully deployed application. So I just want to know where I missed that. So cool.
Yeah, and that's part of why we chose this demo is that I think a big part of the power of Bolt is being able to use, like I said, existing Puppet code to do things like deploy applications, stand up web servers, etc., pretty quickly and easily, but without all the like Puppet infrastructure or the ongoing management or needing to install an agent and master, etc. So yeah. Onwards, you can install Bolt from this URL. So it's pup.pt/install Bolt. It's just a system package, pretty straightforward. So again, taking a step back, like Tom said, that was kind of a big demo to digest. So we'll kind of go back to the beginning and explain how we got to that complete workflow. So Bolt at its core is an open source command line tool that is meant for orchestration and configuration management. You can also think of it as an ad hoc remote task runner. So from your laptop or Bastion machine, you would run Bolt and execute commands or scripts or tasks or plans across many nodes in your infrastructure. It can scale to more than 1,000 concurrent connections and uses industry standard protocols, SSH, WinRM, Docker. You can run it directly on localhost without even like an internet connection. And it uses authentication methods, so password and public key. And worth noting, it does not require running a puppet master or an agent.
So when you first get started with Bolt, the best thing to do, as always, is type Bolt help, which will show you what all the other commands you are. And then if you type Bolt and then the command you want, and then help, you'll get even more information about that specific command. So there's a set of really simple commands with Bolt, starting with Bolt command run, which allows you to say like Bolt command run cat etc hosts, and then give it a list of nodes, and it'll connect over SSH or WinRM, run that command, collect all the input, and display it to you. So this is really great if you have, if you just want to debug something, or you know a quick fix to a problem and you want to make it so. You can also use it to upload files to the remote target if you want to copy a configuration file to test something out, etc. It will copy a script over and run it. It will copy a task over and run it, which is more or less just a script, but we'll get into that later. And it can manage all of the Puppet code. So there's thousands of Puppet modules on Forge. You can list those in a Puppet file in your Bolt project directory, and then just type Bolt Puppet file install, and it will get all of the content it needs to run the plan or run whatever work you want to do.
So the demo that we just showed you involves running a Bolt plan. What is a plan? Might be the natural next question. So a plan composes separate tasks, and by tasks we mean like steps or functions. So it doesn't have to be a Bolt task. It can be running a command, running a script, uploading a file, any of that functionality, and it can compose them together in meaningful ways. So we can process outputs, like Alex returned that JSON object. We can compute inputs, so have like a variable that gets the result of a function, passes it along. Plans are written in the Puppet language, and they include many plan functions, such as run task, and there's a number of others which are documented in our documentation. And in that way, you can almost think of plans as like Bolt's scripting language of just calling multiple functions and processing the input and output of each of them. Plans document their parameters. So if you run Bolt plan show, it will show you all of the parameters for that plan and their types. So integer, string, etc. And lastly, plans live in the plans directory of a module, which is how Bolt is able to load and run them.
I can show you the, oops. So this just gives you a little usage example here, and it tells you what the parameters are.
Yeah, and if you want to see more of the like plan infrastructure, this demo is available at GitHub on /puppetlabs/brownbag-demo. I think we showed that link a little earlier in the video, but you can do more exploring there of like what a plan looks like and how it fits into a module.
We'll make sure to get that in the show notes on the YouTube post as well.
So apply blocks are how you can apply like declarative Puppet code inside the plan. So Puppet has long had like a really powerful declarative model for configuration management, where you describe a state, and then Puppet ensures that state exists. The plan itself is more imperative. It's kind of a script that goes through, and there's workflow steps and logic that happens, but it executes from the top to bottom, basically. And with apply, you can describe a state at a specific point in time, and Puppet and Bolt will ensure that that state is present on the targets, and then it'll come back and do the next declarative step. So this means you can sequentially describe different states. If you have like a complex application bootstrap and you need to have put all of the nodes in a cluster into maintenance mode while they pass keys around, and then you can describe this final state where they're not in maintenance mode. It means you can just use all of the thousands of existing Puppet modules for stuff like Grafana or Telegraph. Oops. And what did I do? Wrong way. But it also, like if you just want to do normal Puppet, but you don't want to worry about a master or an agent, you can just use bolt apply as a command, and all the code can be kept centrally. You can check it out on your laptop, and then Bolt will make sure that whatever needs to get to the target gets there, and just the minimum amount that's needed to actually apply the manifests you care about. So it's a great just masterless Puppet workflow in addition to being able to just sequentially do stuff in a plan.
Yeah.
Oh, I was going to show the
yeah,
what some of the Puppet code looks like.
Good idea.
So for example, this is where I took the Grafana module and I just pass in all the options I need to it. So and then the InfluxDB, and I pass the options I need to that. I kind of just declare a bunch of Puppet resources that someone else wrote and published to Forge. And this is really all I wrote to manage Grafana and PuppetDB for this plan and for that demo.
So we got a question in from Graham. So is Bolt best used by existing Puppet users, or is it appropriate or good for a non-Puppet customer or user to integrate Bolt?
I think it's appropriate for both. I mean, I think it's really great for Puppet users and people who have Puppet code. They can take advantage of it immediately with Bolt, and that's really powerful. But just in its own right, it's a really powerful tool. And if you want to get started with like a new configuration management tool or a new orchestration tool, you don't need to have existing Puppet code because there's all that code on Forge written for you.
Yeah, and you don't need to have like knowledge of Puppet either. Our most run command, according to our analytics, is bolt command run, which just runs any like system command. So I think things like remote troubleshooting, we've heard a lot of use cases where people have like 500 machines that have the same issue, and instead of having to go to each one and fix it, or like write like complex management to try to fix it on all of those, they can just with one command fix it from their local machine on like all 500.
And as we'll get to a bit later with tasks, you can kind of do a lot of the heavy lifting in whatever language you want, if it's Python or PowerShell or Ruby. Like very little of what you do has to actually be in the Puppet language. Most of the work can be pushed off into tasks.
Mm-hmm. But yeah, good question. So yeah, we have the concept in Bolt of an inventory file, and we kind of skipped talking about Bolt's configuration in this demo just because we felt like it was implied or obvious, I guess, that Bolt has a configuration. There's a file, you can set lots of parameters. But one thing that's unique to Bolt is that you can do per node configuration. So you can store information about your nodes in your inventory file. And you can either statically have just your host names in the inventory, or as Alex did in the demo, you can have them dynamically added to the inventory in your plan. And then you can set configuration on those nodes. So you can say, for this group of nodes, always use the SSH transport and use this user and this password, or always have this connection timeout, stuff like that. So that allows you to not have to like be able to connect to multiple machines in the way that they need to be connected to without needing to run multiple commands with each configuration specified with each command. So yeah, we'll take a look at this inventory file that we used for the demo. Is kind of a skeleton inventory. And that was because we wanted to create those groups dynamically in the plan. So we have these like empty dashboard and agent groups, and then from the plan, we can refer to those groups by name and not really care about the specific host names of the nodes that we put into those groups. And then if we wanted, we could set configuration specific to those groups as well. But instead, we just have a like general configuration for all of the groups, which is to set the SSH host key check to not happen, so we don't have like a false host key check or a incorrect host key check if we SSH a new machine we haven't SSH'd into.
So another really powerful feature of Vault is that it ties into Huayra. So from inside those apply blocks, you have full access to Huayra data. Huayra is a like node-specific data backend for the whole Puppet ecosystem, and this means you can you can pull your data out of your code, so I can separate the logic for how I configured Grafana from like what the specific name of the database is, and then I can reuse that class a lot of different places. It also has a whole bunch of pluggable backends. So in this case, my Huayra is just in a YAML file, but I could also tell Vault to get Huayra data from Vault or from a database. So it could be loaded externally from the code and the project itself. When it makes a request for data, it sends the facts for the thing it's talking to. So you can have a complex hierarchy or tree of how data is looked up that makes it easy to easily set the data you want. So I can set some values based on the operating system and perhaps other values based on what data center the node is. And finally, maybe just some values purely on the node name or something. This is the simple data file for this. I'm setting the Influx database and username to Bolt, and I'm setting the password for InfluxDB and Grafana here. In the real world, I could encrypt these in this file and then supply an encryption key when I want to run the plan, or I could be loading them from Vault or something more secure.
All right, so the fabled tasks that we've been talking about. So tasks are really just scripts that are kept in modules and have metadata. So that makes them really easy to share across an organization and be able to like explain what they're doing and how they should be run by Bolt. So tasks have JSON metadata, which has a couple of different parameters. Again, this is all enumerated in our documentation. And it's stored in a JSON file, which lives next to the task script. Tasks can be in any language that your target can run. So again, Ruby, Python, PowerShell, Bash Shell, anything, as long as your target can run it, we're not picky. just like with plans, they also have self-documenting parameters. So those are usually enumerated in your JSON metadata, and then when you run bolt task show, it will show the parameter and the type, and you can add a description as well of what that parameter is. And just like plans live in the plans directory of a module, tasks live in the tasks directory. So this is where we were talking a little bit earlier about if you're not already a Puppet expert, how useful Bolt can be. This is, I think, the place where Bolt also can be super powerful in terms of allowing you to like distribute your scripts easily across your team, and then being able to use those across your infrastructure with a couple of keystrokes.
So, Lucy, you're fading out a little bit. So it was a little quiet, but we're good.
My bad, but thanks for telling me.
Yeah, no problem.
So yeah, Alex is running a task show in one of our built-in tasks, which is the package task, and we can see it's got 1, 2, 3, 4 parameters, an action, a name, a version, and a provider. They each have a type and a description, and you can see a little usage blurb as well.
We have, to make it easier to write tasks, we maintain some helper libraries in Ruby and Python, so that it's easy to quickly write a script. You can just write a method or function that does what you want, and it'll handle all of the input and output handling and error handling for that, which means that when you do use it in Bolt, the plan author doesn't really have to think about the specifics because all the tasks kind of have the same input and output format, and it's documented. So this is what that floaty task is. It really is just calling out to a command line tool floaty, so it parses the input as JSON, and it then gives the output back as JSON. So if you want to learn more about Bolt or you want to use Bolt, these are some great resources. The Bolt Slack channel on the Puppet community Slack is really active. If you have any questions, please come there and talk to us.
It's so active that we couldn't get through this without Alex getting notifications from it.
The Bolt project on GitHub, if you want to look at the code or file issues, you can do that here. We recommend you don't install it directly or don't run it directly from GitHub, because we kind of like that package task. There's a bunch of extra content we include with the package. So we encourage people to install the package, not from GitHub, but it is there if you want to play with it or look at it or even use it. The documentation is on puppet.com/docs. We have a lot of documentation here. It goes through various use cases for Bolt. In addition, we have a series of lessons for getting started with Bolt in this hands-on lab. So this will walk you through setting up some initial local VMs so that they're standardized and all the next steps work. And then there's lessons for how to do inventory and how to run a command and how to write a task and how to write plans. So there's, I think, 11 lessons here or something now. And if you just want to play with it, this is a great place to get started. You can try some stuff here, and then from that move on to whatever real problems you have. The Puppet Learning VM has some orchestration and task stuff now. So if you want that, you can get a VM image, and there's some interactive lessons in the Learning VM. This is the demo. So one thing we didn't kind of talk about is Bolt is really easy to embed in your own project or to create a repo of just for one Bolt, like a set of Bolt code. And that's what this is. You can download this, and as long as you're inside of it, it will use the like Puppet file from here and the inventory from here and all the code that is in that repo. And finally, if you want to take part in product surveys or user testing, please email testpilots@puppet.com. We are always looking for people. Whether you want to use Bolt or Puppet or not, we would like to talk to you.
Yay. Are there any questions? This was Bolt at about 80 miles an hour. We have started to do workshops that are like, I think 4 or 5 hours that get people more like writing their own plans and tasks. And yeah, anyway, the Bolt in 30 minutes is a lot, we know. So are there any questions?
Yeah, there's one, and Graham, we may need you to to clarify. I'm not exactly sure I follow, but can you pull in nodes from Active Directory groups? So is Bolt able to use Microsoft Active Directory?
There's nothing built into Bolt to do that, but if you can write a task that queries Active Directory or a function in Ruby that queries Active Directory, you can pretty easily run that at the top of your plan and like put it in inventory. Like it will, like I did here where I asked Floaty for some things to interact with, you can plug in really whatever you want to discover the inventory you're going to act on.
It was for pulling the inventory in from Active Directory groups. So yeah, sounds like that's it. And I have a question about the actual infrastructure and behind the scenes, what you need to run this and how is it licensed? So do I need to set up servers? How many running virtual machines do I need? That sort of thing.
Yeah, you just need your laptop with Bolt installed, and then any machine that has access to, or again, you can, it doesn't have to be from your laptop, it can be from any machine that has Bolt installed. But that's really it. We have a list of platforms we support, I guess, is like our system requirements, but I don't think there's anything unexpected.
So it's not a like client server thing where we'd have a virtual machine with some queued up VMs ready to go. It would just pull the code down and start working.
Yeah,
yep.
On your laptop, on your Bastion, whatever. It is Apache 2 licensed for those that are interested.
That's great. Yeah, sounds like it would. It's a good way to get started and with the automation and configuration management on a small or medium business scale. And of course it scales up, but it's a good way for someone to dip their toes in.
Yeah, it is really easy to start using the tools that you already know. So again, just scripts or commands on the command line, like the things that you already use every day. And then just scale that to your infrastructure. So in that way, it is, yeah, really easy to get started and then slowly kind of build up that knowledge and the resources you need to do more complex orchestration tasks.
That's great. Some comments about how it looks great. It's good. So how can we get a hold of you guys if we want to reach out and ask some questions, have some follow-ups?
Yeah, so that Bolt Slack is definitely the best place, I think, to reach us and interact with the community. Yeah.
All right.
We're pretty responsive. We have one night owl on the team who will respond at 10 p.m. and then I'm the early bird. I'll respond at about 6 a.m. local time, Pacific time.
Yeah, so that's almost 24/7 response time right there.
Yep.
All right. Well, this has been great. Thank you so much for presenting for us. If you have anything else, or do we want to go ahead and call it a night?
Thanks a lot. This has been fun to show.
Yeah, thank you so much for having us.
Yeah, it's great. Yeah, it's very interesting, and as they're saying in chat, something great to look into. So thanks for showing it.
Awesome. Thank you, Tom.
Thanks.
Thanks.